Hey everyone, welcome back. In this video, we're focusing on how to define the high-level system architecture. If you watch a previous video, I guess you will be able to nail the requirements. So once you have nailed down your requirements, by the end, you will know exactly which components to discuss and how they fit together in a system design interview. So let's start quick. We'll talk about the main components overview. First, we will talk about the clients. First, we talk about the clients. The clients, like maybe web, mobile, or backend services, making requests to your system. Next, we will talk about the APIs and load balancers. APIs handle incoming requests. Load balancer distribute traffic across multiple servers to prevent overload. Next, we will talk about the databases, SQL versus NoSQL, like choose based on data structure, scalability needs, and transactions requirement. Also, you need to think about replication strategies like master-slave database, sharding, etc. for high availability and performance. We have here caching, like store frequently access data to reduce latency and lighten database load. Tools like Redis or Memcache are common for that. And we have here the message queue for asynchronous processing. It's great when tasks don't need instant results, sending emails or processing large data. Lastly, we have CDNs. It speeds up content delivery by caching files in geographical distributed servers near to the user. Okay, let's go next and let's make an example of designing a ride sharing service, for example. So first we need to talk about the mobile app and backend services, like riders and drivers maybe will use a mobile app that communicates with the backend via APIs. We talk about real-time matching system, for example. I would say like assign drivers to a rider based on proximity and availability. This can be done like through a load balanced API that scales with user demand. If we want to talk about database, I guess we store the trip history, user profiles, and other structured data. You might opt for NoSQL solutions for high write throughputs or SQL database for complex queries. If I want to talk about caching, it keep active drivers location in cache for quick access, so the system can update and retrieve location data rapidly. Next, we have the message queue. If you need to send the right recipients or handle less time critical tasks, queue them. You can queue them for asynchronous processing. And lastly, we can talk about the CDN or the content delivery network. It hosts static assets like images, style sheets, etc. on a CDN to reduce load on your servers and improve the performance. Okay, let's talk about key architectural considerations that we need to think about. First, we will talk about scalability. You need to make sure components can handle spikes in traffic, like a driver surge during rush hour, for example. If we want to think about reliability, we need to implement redundancy and failover mechanisms, like multiple database replicas. If I want to talk about performance, use in-memory caches and load balancing to ensure low latency responses. If I want to talk about security, protect APIs with authentication and secure data at rest with encryption. And lastly, if I want to talk about monitoring and observability, it set up tools to track system health and quickly pinpoint issues. So let's talk about the conclusion now. Defining the high-level design, the high-level system architecture is all about painting the big picture from clients and load balancers to databases and caching layers. By illustrating how data flows and where each component fits, you will show the interviewer you have solid grasp of how to build and scale a real world application. So yeah, that's it for this video, and see you in future videos.